Okay, today in class we're going to be finishing section 1.3 and our focus is going to primarily be on factoring and different types of factoring. So last class we looked at factoring using GCFs. So I'd like for you to practice this startup problem and then take a look at your answer and check it and make sure that you've got it correct. Okay, so this is what you should have gotten for your answer, so just check and make sure that you did get that. Okay, so we're going to be looking at factoring trinomials today, and the first type of trinomial that we're going to look at is those that have no leading coefficient or just have an understood one as the leading coefficient. So with these, we're going to be factoring these into two binomials when they're factorable. I will say not everything is factorable. Some things will be prime. But if we look at this, what we want to think about is we want to think about the factors of 28 that are going to subtract to give us 3. So that's kind of how we want to approach this when there is just a 1 as the leading coefficient. So looking at the factors of 27, we've got, the factors of 28, we've got 1 and 28, we've got 2 and 14, we've got 4 and 7. So if we look at these factors here, we want to think about which of those would subtract. So whatever this symbol is going to tell us whether we add them or subtract them. Subtract to give us 3. So obviously that's going to be this factor here. So set of factors. So we're going to have x minus 4, and we're going to have x plus 7. Because we want to make sure that when we look at this, we need to have the same sign here. So we need it to be a positive 3. So that means we need this to be a negative and this to be a positive in order for it to end up to be a plus 3 here. So we'll have x minus 4 and x plus 7. If we want to check it, then we could always FOIL it back out. So we would have x squared plus 7x minus 4x minus 28. And we can see that that would be x squared plus 3x minus 28. And so therefore we've done it correctly. But our answer when we're asked for the factorization is going to look like this, not this. This is just checking your work with that. Okay, so here's another one. We want to look at the factors or what multiplies to give us 12 and adds to give us 7. So if we look at the multiples of or what multiplies to give us 12, we'd have 1 and 12, we'll have 2 and 6, and we'll have 3 and 4. So looking at which ones add to give us 7, that's going to be this set here, the 3 and the 4. In this case, we need them both to be positive so that they add up to 7. So we'll have an x plus 3 and we'll have an x plus 4. And you can definitely go back and check that one as well to make sure that you factored it correctly. Okay, so those that have a 1 as the leading coefficient are not too difficult to do. I'm going to introduce you to a method called the bottoms up method. I really like this method for factoring trinomials when there is a coefficient in front of it. If you do not have a leading coefficient, or when I say don't have a leading coefficient, obviously 1 is understood to be there, then you don't need to do the bottoms up method. It's just going to make it longer and more drawn out. So if you have 1 as your leading coefficient, then you would do what I was just doing on the two previous examples. But if you do have a leading coefficient here, the bottoms up method is going to be an easy method to use. You may have done trial and error before for these type problems, or you may have done a method called grouping. I'm going to briefly go over a grouping just in case that is how you have learned to do these in the past. But I've found in working with students over the past few years that the bottoms up method is one that they really do like and can learn how to do these easily. Okay, it looks like there's a lot of steps, but once you practice them a few times, it actually comes pretty quickly. So first of all, make sure that your trinomial is in standard form, which means x squared is first, and then your x term, and then your constant. So it needs to be in this form. Second thing, make sure there's no greatest common factor. So if I had a greatest common factor here, I'd want to take that out. So we need to kind of do these preliminary things before we really get into the bottoms up method. Okay, so this says we're going to multiply a and c together and rewrite it in the form x squared plus bx plus ac. So basically what we're going to do is we're going to multiply the first term and the last term together. So when I multiply 6 times negative 5, I'm going to get negative 30. Okay, so I'm going to go and I'm going to rewrite this. I'm going to leave off this coefficient here, and I'm going to replace the last term with this value that I've come up with. So I'm going to have x squared plus 13x, so this one stays the same, and then replace this with the negative 30, which is multiplying these two together. Okay. Once I get it to this point here, now it is a trinomial with a coefficient of 1. So we can look at the way that we did our previous problem. So we want to know the factors of 30 that are going to, or what multiplies to give us 30 and subtracts to give us 13. If you look at all the factors of 30, you're going to find out that that's 15 and 2 that are going to multiply to give us 30 and subtract to give us 13. So we would factor it to be x plus 15 and x minus 2. Okay, this is the place where we actually use the whole bottoms up method part. So we're going to go in and take these numbers and divide it by whatever this leading coefficient was. So the leading coefficient was 6. So we'll divide this term and this term by 6. And that's going to leave us with a fraction in some cases. Okay, so if you don't have a fraction, that's fine. That means you're done and you don't really have to do anything else. If you do have a fraction, then you need to simplify the fractions. So 15/6 is going to reduce to 5/2, and 2/6 will reduce to 1/3. So simplify those, and then this is the bottoms up part. We're going to take this denominator and we're going to bring it right up in front of the x. And we'll do the same thing here. So this 2 is going to go up in front of the x, and we'll have 2x plus 5. The 3 is going to come up in front of the x, and we'll have 3x minus 1. And this is the factorization of this original problem up here. If you wanted to fill this out, you could easily do that and check to make sure. And I would really encourage you to do that just to make sure that you've done these correctly. Okay, so while grouping is not my favorite method, I do want to briefly go over it just because some of you may be familiar with this. With the grouping method, you're going to multiply the coefficients of the first and last term together. So here we'd multiply these together and we get -6. We want to find the factors of the term that add up, factors of that number that add up to the middle term. So if we're looking at the factors of -6 that add up to -5, you can see our list of factors here, and you do have to consider the positives and the negatives for each of those. And you see that 1 and -6 are going to be the ones that that will add up to the middle term of -5. You want to rewrite that using these numbers here. So we'll have 1x and then -6x for the middle. Okay, well, looking at this, we're going to group these together, and we'll take out the greatest common factor of this term. So we'll take out an x, and we'll take out the greatest common factor here, which will be a -3. And so we need these to match up exactly. So if you were thinking just a +3, then our signs wouldn't match up, so you have to actually take out the -3 there. And then we're going to combine this part and this part together in one parenthesis. So x minus 3 will go in this parenthesis, and 2x plus 1 will go here. So if you're familiar with the grouping method, then it's fine to go ahead and use it. If you're not familiar with it, then I would say don't use this method and use the bottoms up method. Okay, so when we are factoring trinomials, you can do the grouping method, you can do the trial and error method, or you can do the bottoms up method, which is the one that I would recommend doing. Okay, so here's another one to practice on. I'm going to go through it again using the bottoms up method because I think we need to demonstrate that a little bit further. But if you want to do the grouping method, then go ahead and do the grouping method. Okay, so we're going to multiply these together, and we're going to get -30. It just so happens, I think, that our two examples ended up being -30. I'm going to rewrite this. When I rewrite it, I'll leave off the 6. So I'm going to have x squared plus 7x. And then I'm going to put the last term as -30. Okay, so now I need to think of the things that multiply to give me -30 and subtract to give me 7. So that's going to be 10 and 3. Okay, so I'm going to have a plus x plus 10 and x minus 3. If I check my middle terms, positive 10x and minus 3x will give me a 7x. Okay, so I'm at this point here. Now I want to divide each one of these by my leading coefficient. So I'm going to divide it by 6. Then I want to reduce these fractions. So I can see that 2 goes into each of these. So 2 goes into 10 5 times, 2 goes into 6 3 times. And here 6 is going to reduce to 1/2. So reduce the fractions. And now we'll do the bottoms up. So I'll have 3x plus 5. And we'll do the bottoms up here. And we'll have 2x minus 1. Okay, here are a few problems that I would like for you to practice with. Some are trinomials with 1 as the leading coefficient. Some are trinomials with something besides 1 as the leading coefficient. Some have GCFs. So I want you to decide which type of factoring you need to use at this point. Okay, so you can check your work here. If you look at this trinomial, this one has a leading coefficient of 1, so there's no need to do the bottoms up method. We're just strictly going to look and see what factors of 16 or what multiplies to give us 16 and adds to give us 8. So with that, we're going to have 4 and 4. 4 and 4 multiply to give us 16 and they add to give us 8. So our factorization is going to be x plus 4 and x plus 4, which we could write as x plus 4 quantity squared. Down here we need what multiplies to give us 3 and adds to give us 4. 3 only has 2 factors, 1 and 3. So we want it to okay, so we want to make sure that we get our signs right on this. So we need them to end up adding up to a -4. So we need this to be a -3 and a -1. If we check this out, we end up with the -4x in the middle. -3 times -1 will give me a +3. Okay, on this one, you really want to be sure that you took out the GCF first. So my GCF would be a 7 and an x. So I'm going to end up with x squared plus 2x plus 1. Okay, so the GCF is not the only type of factoring that we need to do in this problem. That's the first type. So remember, always do the GCF first. And then beyond that, we still have a trinomial here that we need to try to factor. So if we look at that, we want the factors or what multiplies to give me 1 and adds to give me 2. Well, 1 only has the factors of 1. So this is going to be x plus 1 and x plus 1, or 7x times x plus 1 squared. Okay, here we have a trinomial with a leading coefficient, so this would be a bottoms up problem. Multiply these two together and we get -6. So I'm going to rewrite it as x squared minus 5x minus 6. Okay, when I go to factor this, I need something that multiplies to give me 6 and subtracts to give me 5. So that would be 6 and 1. I need the 6 to be a negative and the 1 to be a positive for me to end up with a -5x in the middle here. Okay, we want to divide by our leading coefficient. So our leading coefficient's 2. Simplify our fractions. And then do bottoms up. This one has nothing to do bottoms up with, so it'll stay at x minus 3. This one will do the bottoms up and bring the 2 up in front, and it'll be 2x plus 1. Okay, we have some special factoring formulas that you need to be familiar with these. The first one here is the difference of squares. Notice we do not have a sum of squares. It is not possible to factor sum of squares. It is possible to factor the difference of squares. So this would be the rule that we would be using here. On these, if you have, I'm not as concerned about 2 and 3 because these would factor by normal methods. In fact, we were doing some where we ended up with the same parenthesis and it would just be written to the second. So I'm not too concerned about those. And we will look at 4 and 5 in detail because they are very helpful formulas that you'll need when doing the difference in sum of cubes. Okay, so looking at these, if we go through and try to factor for the difference of squares, the first one here that we have, we've got 4x squared minus 25. So you really need to be familiar with your squared terms. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81, 100, 121, 144, and so forth. I'm not going to write all of them out, but these are your perfect squares. So when I look at a problem like this, first of all, always even on these, take out your GCF if you have one. We don't have a GCF here, but I do see a perfect square and a perfect square. So that, and I have a difference. So that tells me I can factor it as the difference of squares. So this is going to set up as into 2 parentheses. So I want to think, what did I square to get 4x squared? Or what's the square root of this? So the square root of 4 is 2. And then the square root of x squared would just be x. The square root of 25 is 5. And with the difference of squares, you're always going to have a positive and a negative. And I didn't put my 2 here. Okay, this would be 2x plus 5 and 2x minus 5. Here we see another difference of 2 perfect squares. So the first one, we square 4 to get 16, so that would be 4x. And then we square 3 to get 9, and we have a plus and a minus. On this one, we've got perfect squares again, so we'll have 5x and 7, and then 5x and 7 again with opposite signs. Here we have x squared, so we square just an x to get x squared, and we square a 1, and we'll have opposite signs. This one we have an addition sign, so it's going to be not factorable. This one we've got 2 perfect squares, so in the first one, the first term is going to be an x in both parentheses, and the second term is going to be a y because that's what we square to get y squared. We'll have a plus and a minus. And then here we have a plus sign, so this one is again not factorable. So it's very helpful if you are familiar with these perfect squares so that you can recognize them easily in your problems. Sometimes they may not be perfect squares to begin with, but if you factor out your GCF, then you may be left with a perfect square. So moving on to factoring the difference and sum of cubes. This requires a special formula to factor these. And you can see that here we've got a to the third minus b to the third is going to factor into a minus b as one parenthesis, and then a squared plus ab plus b squared for the second parenthesis. This will always be a prime trinomial, so there's no need to try to factor this any further. So if we look at factoring this, we've got to figure out what our a is and what our b is in this. So looking at this, I need to think if I were to take the cube root of this 27x to the third, in order to factor it, this should be a perfect cube. So the cube root of 27 is 3. Cube root of x to the third is just x. And so that's going to be my a. If I do the same thing, the cube root of 1 is 1, and that's going to be my b. Okay, so I'm going to take this formula and basically just plug in the a and the b. So it's going to be equal to 3x minus 1, and then I'm going to have 3x squared plus 3x times 1 plus 1 squared. Okay, I would recommend just waiting about simplifying this to go ahead and write this first step out so you can see where everything's coming from. So then we'll have 3x minus 1. 3 squared would be 9, and then x squared. Here we'll have plus 3x, and then we'll have 1. And that should be our final answer for this one. Okay, moving on to one where we're looking at the sum of cubes. You can see that the formula here is very similar with just a difference of signs to work with. So if we're going to factor this one, which is x to the 6 plus 8, we need to look at what's the cube root of x to the 6th. And we talked about in a couple earlier sections doing a cube root of something like x to the 6th. We know we need groups of size 3, so this would end up being x squared. If we look at the cube root of 8, that's going to be 2. So this would be my A, and this is going to be the B. So I'll just apply this rule here to factor it. So I'm going to put in the place of this A, I'll put in x squared. In the place of the B, I'm going to put in 2. So I'll have here an x squared squared minus an x squared times 2 plus a 2 squared. So I've got x squared plus 2. Here we have x to the 4th minus, this would be a 2x squared, and then finally a plus 4. Okay, I have a few for you to practice with, so I would like for you to pause this and try factoring these. Some deal with trinomials, some with GCFs and difference of squares and so forth, so it's just a few more practice problems. Okay, check your work on these problems where you were asked to factor. The first one, you need to do the bottoms up method because you have a coefficient in front here. You could see that this is the answer that you should have gotten. This one, there was no need to do the bottoms up method. You could just basically do the trial and error and get that factored. This one, you needed to take out a greatest common factor on. And then this last one, if you look at it, it has a greatest common factor that needs to be taken out of it. So you have to take out the 4 first, and that leaves me with 4 minus t squared, and then I can factor that as the difference of squares. So this would not be appropriate to have 4 minus 2t and 4 plus 2t as the factorization for this one. Okay, a couple more that we want to factor and make sure that we can factor completely. We always want to start with our greatest common factor. So we're going to take out the 2 and an x squared. So I'm going to be left with x squared minus 4. And anytime we have anything that can be factored further, we need to do that. So we have 2x squared. This is going to factor into x minus 2 and x plus 2. And I apologize for the pen. 2x squared times x minus 2x plus 2. Okay, here's another one. We want to start by taking out our greatest common factor. So we'll have an x and a y squared. So it's going to leave me with an x to the 4th minus y to the 4th. Okay, this is actually the difference of perfect squares. So this will factor into x squared minus y squared and x squared plus y squared. Because if I square x squared, I get x to the 4th. If I square y squared, I get y to the 4th. So, so this will factor, and I can't factor this any further because it's the sum of squares, but I can actually factor this one even further. So sometimes you get a problem where you just keep going with the factoring. So this would factor into x minus y, x plus y, because it's the difference of perfect squares. And then this one's going to stay the same because I can't factor the sum of squares. Okay, looking at this, we want to be able to factor out fractional exponents. So when we look at this, I want to give you an example here. Okay, when I go to take out my greatest common factor on this one, what I see is that I take out each base to the lowest power. Okay, so like on this one, I would take out an x to the 2nd, and I would take out a y to the 1st. So I'm going to do the same thing here when I have these fractions as exponents. I'm going to take out my smallest power. So on this particular one, my smallest power is this negative 3/2. So I'm going to take out x to the negative 3/2 and see what happens. Okay, so if I take this one out, I'm just going to be left with 1. Here, I've still got the 2. When I factor out, factor is like division. Okay, so I'm going to be dividing, which means I'm going to be subtracting my exponents. So I'm going to have this negative 1/2 here, and I'm going to subtract the one that I took out. Take out the negative 3/2. So I'll have negative 1/2 plus 3/2 will leave me with 2/2 or 1. So that's my exponent for my x. It would be to the first power. And then I'm going to do the same thing here. I'm going to have a positive 1/2, and I'll subtract what I'm taking out, the exponent that I'm taking out. And I'll have 1/2 plus 3/2 will give me 4/2 or 2. So this is going to be x to the second power. So just to kind of recap on this one, take out your x to the smallest power. So if I look at these exponents here, the smallest one of them is the negative 3/2. So that's what's going to come out. And then when I go to divide, I think it's pretty clear that this would be a 1. But here, I had x to the negative 1/2, and I'm going to divide or factor out an x to the negative 3/2. So I'm taking this negative 1/2 here, and I'm going to subtract from it what I took out. So these are just simply the powers that I'm working with down here, and combine those, and I get x to the first and on this, and x to the second on this one. Okay, here's one for you to practice with. Okay, you can check your work on this, and this actually would go ahead and factor a little bit further. This would be x to the negative 1/2. This will factor into x minus 2 and x minus 1 for the complete factorization of it. But as far as this part goes, we look at our exponents, and the smallest one is this negative 1/2 exponent. So that's what we're going to take out, along with the 3 that's also a GCF. So if I take that out, then here I'm going to start with the 3/2 that I had, subtract because we're factoring, which is division, which means subtract our exponent. And then I took out the negative 1/2, so that's going to go here. So 3/2, two negatives make a plus, and I combine these together and I get 2. That's the exponent that goes here. When I look at the next one, I'm going to start with the 1/2 exponent, and I'm going to subtract from that the negative 1/2 that I'm taking out. So I end up with 1, and that's going to be the exponent that goes here. And then this is just a trinomial that's factorable, and so it goes one additional step there. Okay, the last type of factoring that we're going to take a look at here is factoring by grouping, and this is an easy one to end on. With grouping, it needs to have 4 terms. Okay, so if you have an expression, a polynomial that you're asked to factor and it has 4 terms, grouping should be your first thought in trying to factor that. So we want to group it into 2 groups. We'll group this group together and this group. Occasionally you need to rearrange them, but on this one we're not going to need to. So I want to take out the GCF from each of these 2. So my GCF here is x squared. So that leaves me with x plus 1. Be sure that you put the 1 here as a placeholder. Otherwise, when you distribute it back through, you don't end up with what you started with. Here, if we take out the 4, we're going to end up with another x plus 1. It's essential that this one and this one match. If they don't match, you can't go any further, and you need to kind of look at your work and see what's happened with it. So here I'm going to take this term and this term, and I see that I have a common factor of x plus 1. So I'm going to factor that out, and that's going to leave me with this x squared and this plus 4. And that's as far as I can go. So that's going to be my factorization. This one can't be factored any further because it's a plus. If it had ended up being a minus, then I would need to, because it would have been the different squares. Okay, here's another one. We want to look at factoring, grouping these together. We've got 4 terms, so grouping should be the method that we think of. Here we'll take out an x squared, and it'll leave me with an x minus 2. Here I'm going to take out a 9, and it's going to leave me with an x and a 2. And I'm holding off on putting my sign here because I need to make sure that this is going to be a minus so that it matches up. So in order for this to be a minus, this one actually also needs to be a minus for that to work, because this parenthesis has to be equal to this parenthesis here. in order for us to be able to proceed. So at this point, we've got this term and we've got this term. So we'll take out the x minus 2. We'll be left with x squared minus 9 for the leftovers. This would be left over and this would be left over. And here we see that we have a difference of perfect squares. So x minus 2, this would become x minus 3 and x plus 3. Okay. And that's going to end what I would like for us to do for today. So be sure that you practice your factoring. Factoring is one of those things that it's a very fundamental concept that you need to be familiar with, because we'll continue to look at factoring, not just this year, but if you're going into calculus, you should be able to factor with ease. So really make sure that you brush up on your factoring and feel good about it. Let me know if you have any further questions on it. And if you need to ask any during our Zoom sessions, that will be fine as well. Thank you and have a good day.